All right, welcome back to Prep for Calc. What did we learn about yesterday? I don't remember. Did we have like 1, 2 topics? Trig? I don't think there was trig. There might have been. But I don't remember. Log? I don't remember logarithms. I don't remember any geometry. No functions. Man, what would it be then? Exponents? Rational expressions? I don't remember. Okay, there was 2 composition functions. That is taking the function of another function. Solving rational equations that simplify to a quadratic binomials in the denominator and numerator. So that's what we did yesterday. Nothing really else to note. I'm going to jump back in, continue learning. I'll be back to recall what I learned in a little bit. All right, 2 more topics today. First was solving a quadratic equation with irrational roots. And irrational roots are roots that evaluate to values that are irrational. Okay, that was pretty simple. Using quadratic formula, negative b plus or minus the square root of b squared minus 4ac over 2a. That's how we find the unknowns in a quadratic equation that we can't just factor easily. And then, what was the other? The other problem was, our learning topic was inverse functions. So inverse functions, I was able to remember. I don't know these super well, but I was able to remember what to do, and that is, you basically, it's the function f of x, say f of x equals x. You're basically taking the inputs and making them outputs, and vice versa. Like when you graph it, it's the function where basically like the x and y values are inverted. So for f of x equals x, what would that be? Inverse function would be negative x? How would you do that? I would say y equals x to state the function f of x, y equals x, and then I would switch them. X equals y. F of x, so that, the inverse function of x is x, because all the points are on a diagonal of like 0, 0, 1, 1, 2, 2. So if you flip the x and y points, it doesn't change the values. So I think that's it. Inverse functions, and we had to do domain and range. They were rational expressions, and finding the domain and range. So you got to find the asymptote. So I believe when you have like a single degree variable on top and a single degree variable on bottom, is going to have an asymptote. If the coefficient of the variable in the denominator is greater than the top, and it's going to basically like evaluate to, if you just remove the extra values, the terms, the lower degree terms. It has to do with lower degree terms and higher degree terms. So you look at the highest degree terms, and if the denominator highest degree terms coefficient's greater than in magnitude. Yeah. I think the same variables, degrees variables, coefficient, the numerator, then it's going to have a horizontal asymptote. Basically at the fraction of the coefficients of those terms. So that's it for today. Talk to you tomorrow. See you.